Good evening, everyone, and welcome to yet another webinar from Math Revolution. The topic covered today is very crucial when it comes to GMAT Quant, which is GMAT statistics. So we'll be dealing with a lot of DS and PS problems, some kind of traps. So I would request every one of you to keep your pen and paper ready because there are a lot of takeaways, and complete webinar is all about the question solving. It's all about the various resources and resourceful tips. So these are the 4 pointers that we'll be dealing today and talking about. uh, I'll be talking about math revolution, how do we came into existence, and GMAT math overview, which is pretty common for all. Major agenda is GMAT statistics, which is PS and DS questions. There are a lot of couple of good DS questions at the end of the slides, so I would request everyone to keep in connect. And of course, a question for everyone. The approaches that we learn, are those good enough to in comparison to what we have learned so far, and which one is the time saving and accurate more? Going ahead with this math revolution, we are already global. This is something which I always talk about in my webinar. In 2001, we established in South Korea. We have more than 190 plus countries site visits, and with members of 130 plus countries. It's been like, more than 41,000 students all over the globe we have connected with. 90% of our students have scored 49. The dream score is 50-51, but 49 is one of the precise value or the number that I always talk about. 90% of students, that holds a huge value. This is one thing I always talk about in my webinar. Your goal of GMAT quant is never a 45 pointers. It's always 49, 50, 51. And what is it that can bring it to 50 and 51? It's only the two approaches that can save your life, your time, and make you sure that you perform consistently with a lot of accuracy and can make it easy with 50-51 pointer, which is variable approach for DS and the IV approach for PS. My first two webinars were on where respective of those particular approaches, the variable for DS and IV for PS. You can always see those onto our YouTube channel of Math Revolution. And today's webinar is specifically for statistics. So we'll be dealing with those. But before that, I just want to introduce to the mastermind behind the new approaches. It's a world's first variable approach, which is based on the pattern, which is based on the time saving, the references, the challenges that all our students has faced. So this is something which I want to tell, that Max is the founder and he's the CEO of particular Math Revolution with a master degree in mathematics, and he solved more than 100,000 questions. That itself is a Bible. And he has taken GMAT exam 27 times with a perfect score of Q 50, 51 many a times. So he's the one who has brought this concept of variable approach. These are the two sets of characteristics. Uniqueness is one, which is world's first variable and IV approach that we talk about. Irrelevance of whether you belong to a math background or a non-math background, it is pretty easy for everyone to cover those. So we have designed those for every set of student. Quickness, yes, if you have just 10 minutes to spare before your exam, this particular approaches will save you a lot of time, and you can definitely mark your likely answers to be C, D, E, or A, or B, which will give you upper hand. Accuracy, yes, once you practice and master it, it would be always an accurate about this. Excuse me for that. And let's go ahead with this particular strategies for the score of 50-51. Scoring 50-51 is not a major challenge. I mean, like, if you have a conventional approach and if you have mastered it enough, you can do it. But again, when we talk about the data in total, there are only few who were able to score 50-51 or who can score 50-51, using their expert math skills and all those conventional approach, the long solution method. uh, it's a very negligible percentage out of a whole. But again, if you have weapons like a variable approach for DS, IV approach for PS, if your logics are intact and you are confident about it, then most of you that particular number would flip, and most of you would be able to score GMAT Math 5051. Let's start the agenda today. Again, welcome every one of you. Please make a proper note of it. This would be uploaded to YouTube as well, so you could definitely have the relevancy after this webinar is done for today. So statistics, what are we dealing today? In the general frame, if you have to talk about stats, it's all about data. So we collect data, we analyze those, and we study the data as per various rules, inferences, deductions, logical deductions, and the patterns. What all we deal into data is a mean. So mean is always categorized. So there are averages that we deal with. Mathematical average is always called as mean. Positional averages are always called as median and mode. So we deal with three type of means, which are arithmetic, geometric, and harmonic. The short forms are AM, GM, and HM. These are very pretty common short forms that we use. Most of the notebooks and everywhere we could definitely see it. Apart from this, we deal with median and mode. Range is one of the crucial part of GMAT quant. Normal distribution, it's again very tricky because it's a kind of a distribution that happens, and standard deviation is all time nightmare if you could not get hold of. So these are something which we are going to deal today. So please make sure that you have a proper understanding and writing of all this concept. Let's start with the arithmetic mean. It's a very simple thing. If you have a number of observations, you just add them all, which gives you the sum, and just divide it by the total number of observation, that gives you the arithmetic mean. It's like rightly said, arithmetic mean is equals to sum over number. I know most of you and every one of you know this formula, so that's not a big deal. Now, the main example that over here it is given, it's a very basic example. A plus B divided by 2, that means it's an average of two numbers A and B. X plus Y plus Z divided by 3, that means it is the average of three numbers, X, Y, and Z. Now, if we go ahead with this particular question, what is the average of 2A minus B minus C, 2B minus C minus A, and 2C minus A minus B? I can recollect this fact very easily, that I have to find a mean that is already given to me. I've got five different options to it. So my concept says that the average would be very simple, or the arithmetic mean would be sum over number, that is S over N. If it is S over N, what I'll do is I'll simply add all those and I'll divide it by 3, because total numbers are 3. So if I add those and divide it by 3, it's very simple to add 2a minus b minus c, 2b minus c minus a, and 2c minus a minus b. If you add those, now see, understand, before jumping to, solve, just look at those numbers first. See, this is why I've kept this particular, question into the today's webinar. Before jumping to the, before jumping to particular, you know, particular solution, just talk about one thing, which is, we have 2a here, we have one negative a, we have one negative a, we are adding those. So this 2 times a automatically cancels the remaining negative a's. Similarly, we have two b's, which will cancel out the two negative b's, and we have two c's, which will cancel out the two negative c's. So ultimately, when every number is canceling out each other, the sum remains to be 0. If the sum is 0, your average is all in total 0. So this is what my motto is, to tell, before jumping to solve a PS question, just look at what is given, so that you don't waste much of your time. I know most of you and every one of you would be able to just add it up and divide it by 3, getting the same answer at the end, which is 0. So, this is one thing that I wanted to show through this question. Let's talk about the geometric mean. The concept is very simple. If you have five numbers, just take the fifth root of all those multiplied together. If you have four numbers, just take the fourth root of all those four numbers multiplied together. If you have n numbers, multiply all those n numbers and take the nth root. That is what geometric mean says. So average is, if I talk about arithmetic mean, was adding up all the numbers and dividing by the given total numbers. Geometric mean is finding the nth root of all those n numbers. So for two numbers, it would be square root of a times b. For three numbers, it would be cube root of x times y times z, that is being given into the examples. Let's deal with one of the question. If the average, which is a geometric mean, of 2 and x, so there are two numbers, 2 and x, is equal to the average, which is the arithmetic mean of 1 and 2x. Now, see, there are two concepts that is applicable here. One is the geometric mean. So we know that that's the nth root of. Now we are dealing with two numbers, so that would be square root of those numbers. So we have to multiply 2 times x, and we have to take the square root of it. On the same time, if you're dealing with arithmetic mean also in this question, because the geometric mean is equals to the arithmetic mean, so I'll add up the both numbers. That gives me sum divided by two numbers, which is a number. So calculating each separately, geometric mean of 2 and x would be square root of 2x. Arithmetic mean of 1 and 2x would be 1 plus 2x divided by 2. Now, since the question says that they have to be equal, I have to simply put them to equal. When I put them to equal, now this is wherein the concept of the statistics stop and basic math starts. If you have a radical sign on the one hand side, the only thing which you could do is just root off. So we have a square root sign right now on the left hand side, so we'll just square both the sides. After squaring both the sides, square root of 2x becomes 2x, wherein 1 plus 2x to the over 2 whole to the power of 2 would be expanded. Once we expand this is pretty simple. 1 plus 4x square over 4. 4 can be transferred to the left hand side. It gets multiplied to 2x. It becomes 8x. That is 1 plus 4x square. I can definitely see that this is going towards a quadratic equation. 0 equals to 1 plus 4x square minus 8x. 0 equals to 1 minus 4x plus 4x squared. Just pay attention to it. It is 1 minus 4x plus 4x squared. 4x squared can be written as 2x whole square. 1 can be written as 1 whole square. That means it's 1 minus 2x whole square. So that's a formula or identity that you can use. So far we're just doing a basic math. The statistics was just done in the first step when we have put the geometric and arithmetic mean together equals to each other. 1 minus 2x becomes equals to 0. It's very easy to find x equals to 1 over 2. Mark your answer is E, therein where we have done this job. Let's go ahead with another one, which is a harmonic mean. A typical kind of a harmonic relation we see when we deal with the speed, distance, and time questions, therein where the distance being constant, we deal with the speed is inversely proportional to time. That is a concept of harmonic mean or harmonic averages or harmonic relationship. So the reciprocal of the average of reciprocal of a set numbers, it's not that difficult to understand. If you have two numbers m and n, just reciprocal them. So it becomes 1 over m and 1 over n. Now just add them. You will get 1 over m plus 1 over n divided by 2 because that is how we find the mean. So what we do is we reciprocal it, we find the arithmetic mean of it, and then we again reciprocal it. That becomes the harmonic mean. One concept that I'll tell you over here before we go ahead and solve this particular question. Harmonic mean is a reciprocal of arithmetic mean. That is one case. Secondly, if the numbers are same, there are high chances of you getting arithmetic mean equals to geometric mean equals to harmonic mean. There are chances that you could get. I don't say that they would be equal always, but the relationship between arithmetic mean, geometric mean, and harmonic mean is always in the order of arithmetic mean is greater than equals to geometric mean, which is greater than equals to harmonic mean. So AM would be always higher. This is what I would say is a takeaway for you. GM is in the middle and HM is the last one. So GM is always higher than the HM. So if you have to find the harmonic mean in this question for 2, 6, and 12, my first step of it would be harmonic mean. So I recall the concept that I have to reciprocal them. I make it 1 over 2, 1 over 6, 1 over 12. I add them all. It's not a big deal to add a fraction. I'll add them all, making a common denominator 12, which is taking an LCM of 2, 6, and 12. So my numerator here happens to be 9 over 12. Now I have to divide it by 3 because that is wherein I'm finding the arithmetic mean. Yes. So 9 over 12 divided by 3 happens to be 1 over 4 on the simplification. Now, the only thing which you have to remember here is you have to again take a reciprocal of the numbers. So the result obtained here was 1 over 4. Take the reciprocal of this number, which happens to be 1 over 1 over 4, which makes it 4. So final answer for us for this three numbers, 2, 6, and 12, becomes E, which is 4. That's a harmonic mean. It's standard deviations. Before I start this, I just want to tell you one thing. If you have any question, you have several ways to connect back to me. You can write me directly on Punit, Punit at mathrevolution.com. You can visit the website at mathrevolution.com and arrange or schedule a consultation call with me directly. It is directly there with the Calendly integrated. Or you can definitely book a consultation live on call. That's a free call, and we can definitely talk about your quantity scores, your performance, how you should go about it, how should you plan it. A lot of the students have taken and are taking this calls very seriously these days. And it's pretty open for you as well. You can see the links onto GMAT Club as well. Having said that, let's move ahead with the standard deviation, which is one of the core topic. And the core topic for standard deviation, the more data is spread out, guys, see, understand very clearly. If I've got five values of x, 1 2 3 4 5, I know how to square them. I know how to find the mean of those. I know how to subtract the mean from every single data, and then I know how to square them. I also know how to divide it by total number of observation and then take the square root. But let me tell you, GMAT won't give you that amount of time or data, very much dispersed data to or restricted data to find the standard deviation. The questions are very tricky. It's a standard deviation. Always understand in statistics, there is something called measures of central tendency. Mean, median, and mode are the base of the central tendency. The deviations are always from the data value that you have calculated. So this is something the data analyst, the data scientist, and this all people does today in today's world. So the more data is spread out, the greater the standard deviation. This spread out would be from mean. So if you have a mean and your data is very far from the mean, the standard deviation happens to be the greatest. So indirectly, what I mean to say that is if your numbers are same, suppose 4 4 4, your standard deviation happens to be 0 because there would be nothing called a spread out because you have the same number. So right now on your screen, what you see is how do you find a particular standard deviation for x. I'll come on the variance in the later part. It's e x minus m whole square, which is an expected value. Before you find a standard deviation, there happens to be a calculation of variance. So if you take a square root of a variance, that's a standard deviation. So Sx is a standard deviation of set x. V of x is variance of set x. E of x minus m whole square is the average of set x minus m whole square. This is something I was talking about when you have a data, five numbers. You subtract the mean of all of those, then you take absolute sum of those, then you square it, and then you take a sum of all those particular deviations from the mean. Let's talk about this question. And it's a very close question, DS. So if some of you has attended my webinar related to DS variable approach, let me tell you that I'll be talking in terms of variable approach. I'm not going to talk in terms of long approaches to solve this question. Just to brief, variable approach deals with the original condition, which is a question wherein we find the variables, number of variables given or the equations. And then we see that the conditions, those are given to us, the number one and number two, how many equations those can give. And on the basis of those, we can definitely find a way to mark our possible answers as A, B, C, D, or E. So let's go ahead and talk about the same. In a certain class, 10 students took a math exam. So I have a total data of 10. That is one number I've got. What was the standard deviation of the exam scores of the 10 students? Do I have a data exactly? I've just got how many of those are in the the classroom, or how many of those have taken the math exam. That is 10. But I have not got their various data. How many marks do they have scored? So again, my for me right now, the question is very open. It's a 10 students. If I name them A, B, C, D, E, F, G, H, I, and J, that means it's pretty simple that I've got 10 variables. Now to solve a particular question for 10 variables, I'll require 10 equations. But my this condition number one and condition number two can at max give me two equations to solve. I'm still short of eight equations. My answer goes as E. I've already marked my answer for this particular question, but I just want to show you that I'm not sure that is correct answer, but how do we get through it? So see, it's very simple. I'll just put you on the solution. We'll be applying the variable approach. You know, the more the data is spread out, the greater the standard deviation. Just make sure these two lines are very important. You have a whole data set, you can get the standard deviation, but if you are have any element missing, you cannot get the standard deviation. I don't have a elements here, right? So most likely answer happens here to be E. And if I go ahead, I'll just follow the three steps of the variable approach. I'll just first quickly modify and recheck the original condition, which I earlier did. There are 10 students for which I have to find the standard deviations. I'll match with the number of variables in the original conditions and my given conditions, number 1 and 2. It says 10 variables need 10 equations, as I said before. My answer would be E. So far, I've got the answer. I've not started the solution. This is the beauty of variable approach, which I have been always talking and I will always be talking about. Now let's just see to it. If E is the answer for me, I'm not falling for checking the condition number 1 and 2 separately. So I save a time of my own there also. I'll not check them separately because I just have to make sure my E is the answer and E is my most likely answer. So I'll just simply combine both of them because that is how we mark the answer as E if they don't get sufficient after getting combined as well. So if I combine the condition number 1 and 2, one condition says me that the standard deviation of first 9 smallest score of this 10 students is 80. I'm okay, but am I aware about how much is the 10th score higher? The ninth smallest score of this 10 student is 80. I'm not sure how much higher the 10th score is than the other 9. So I'm not getting a deviation out of it. So that's a pretty unknown. And in the second condition, I say, or it says, 5 of this 10 students have the same score. It's okay. 5 of this have the same score. Their deviation happens to be 0. But what about the remaining 5? Because I'm not talking only about the 5 students as the first or the last. I'm talking whole set of 10 students. So for 5, the deviation happens to be 0. But what about the remaining 5? So in that particular scenario, if you combine both, it's very, very unpractical that I can find the answers for this. So this is not sufficient. Both the conditions combined, and I mark my answer as E, and I just get ahead with it. All right, I'll go very slow on this property. S of standard deviation of ax plus b is equals to mod of a s of x. Now you need to understand this. If suppose there is a set given to you whose standard deviation was given, and if there happens to be addition and subtraction of the elements, or if there happens to be addition or a subtraction in the elements, then what would be the new standard deviation? The second set of operation can be if there happens to be multiplication or division in the given element set, then what happens to the new standard deviation? Always make sure, if we deal about the parallel movement, if there happens to be addition, there would not be any effect on the new standard deviation. But if there happens to be multiplication, it will always affect the standard deviation. Let me tell you, mean deviation, standard deviation, and range are always affected by the multiplication or the division because that is a scaling factor. When you come to the addition or a subtraction, your measures of central tendency always gets affected by it. So you need to be very, very sure about this. Standard deviation is a measure of dispersion, how much dispersed it is. If everything in a set moves by the exact same amount, the dispersion also will shift in the same way. So that is what an addition or a subtraction is. So scaling is one of the factor that you have to keep thoroughly. Scaling only affects standard deviation or range, but when it comes to median, mode, or mean, scaling and you know addition, subtraction, both will be affecting. So let's so that was one of the property that we will use in one of the DS question which is about to come later on. Right now we are starting with medians. It's very simple. I mean, like median, on the GMAT they will often throw you the questions which are basically on the consecutive integers, which has something to do with medians and along with the standard deviations. It's not a very pretty direct question, but we'll start with the basic one. What is the concept of the median? Median is anything. I said at the start, it is a positional average. So it talks about the position. So if there are 5 numbers, 1, 2, 3, 4, 5, I can say first, second, third, fourth, fifth. So first row and one row, it always makes a difference when we hear them, when we write them, or when we sense them. First row is a position, one row is a number of rows that is given to me. So for the median, the best way to always remember is how many terms has been given to you in the particular set of data. So there could be only two possibilities. Either they would be odd or even. If they happens to be odd, I cannot divide an odd number by two. So very simple. I'll just add up one to the odd number set. I'll just divide it by two so that I can get the third position, that is th term, the third position for it. But when it comes to the even position, if there are 10, see, it's very simple. If there are 10 numbers, you can divide 5 and 5. You're left with nothing. So it's obviously it's a n over 2 plus n over 2 plus 1. So it's a fifth and sixth number. So it's an average between the fifth and the sixth number that comes when it is even. But one which you have to always make sure is you have to array the data set properly. What I mean by arraying the data set, that means if you not arrange the data into ascending order, it will clearly change the values for it. So you need to always make sure that you arrange the data into ascending order if it is not being given into the particular question set. Over here, the question says each of the 45 students in a math class took a test. We have already been given with the total number of students in the question, which is 45. Now, see, when you read the question, this is wherein you have to stop yourself when you get a data or the information. Don't just read and just, go through reading the question in one go. Break your question into the part, understand what you have got, write the data which you have or information which you have, so that you can automatically made out that or make out what you have to find out. The table above shows the scores of students and the number of students who got each of this score. So there are 4 students which says the number have got a score of 1. Similarly, we have 5 students for 2. There are 10 students who have got a score of 5. There are 13 students who have got a score of 6. What was the median score on the math test? Now understand, if we have a 45 students, as I said, n equals to odd, we have to just add a 1 to it, which becomes 46. If I divide that by 2, it becomes 23. So 23rd number in this particular case scorecard would be my final median score. I'm very lucky to see that this particular table is already aligned in ascending order. So now your next step would be just start counting these numbers of. So you have 4 students, so that's a frequency. So you have 4 plus 5, which happens to be 9. 9 plus 2 happens to be 11. 11 plus 11 happens to be 22. Till 22, you're on the score of 4. The 23rd score would be definitely the fifth 5. So your median score goes as 5. This is the same solution that happens to be here. 45 is an odd number. It becomes 45 plus 1 over 2 at term. That becomes 23rd term. So to find the 23rd term, just add up. So this is a concept of a cumulative frequency that we apply. So we are adding up 4 with 5, with 2, with 11. Till 11, till score 4, we have 22. On the fifth score, we get to 23. So our answer would be D. Now let's talk about the property of median. Now this is something which is very important, and I would definitely appreciate if you feel like writing, you can definitely. And if you need time to write it, just drop your message on the chat window, which I can read about, or else I go ahead with the content. So the first property is assumption of median. Now understand, a set is assumed to be in ascending order, least to greatest. If not, then rearrange the element. So now if your question says that in that order, then the elements are in the order. So this is something which you have to be very well aware about before jumping on calculations and solving it. Make sure your order is there. Like it says 248, 2849818. It's not in order. It's not in any order. So now when you arrange it, so if I just don't arrange it and I go ahead and find out the value for this, there are 7 numbers. So the fourth number would be my median. That should be 9. But again, if I arrange it into ascending order, my median would be 8. So in this particular scenario, this is wherein I've shown you the difference. What happens when you arrange and what happens when you don't arrange. So always make sure that your data is arranged in the ascending order. Let's go ahead with the property of median, a very well defined property. If you have two sets and if you find the median of those two sets separately, but if you have been asked to find the combined median of the set, or find the median of the combined set, it would always lie between the two sets. So for example, I have a set 1, 2, 3. There are three numbers, so center value would be my median, so that becomes 2. 2, 5, 9, 11. There are four numbers. So definitely the center most two values, 5 plus 9, added to become 14, divided by 2 gives me 7. So this 2 and 7 is my respective medians for two sets. Now, if I combine both the sets A and B, when I take a universal set for each other, I don't repeat the numbers, whatever are there in both. So we get 1, 2, 3, 5, 9, 11. So I have 1, 2, 2, 3, 5, 9, 11. And therein where, because I said frequency does matter here. So it's not just 1, 2, 3, 5, 9, 11. It would be 1, 2, 2, 3, 5, 9, 11. I cannot remove or neglect a data value. So in total, my median happens to be 3, and that 3 lies between 2 and 7. Let's talk about this property now. This is one of the concept. This is one of the property that would be utilized in solving a lot of questions on GMAT quant. If there happens to be a consecutive integers, and we understand what a consecutive integers is, the difference happens to be 1 between those. So even, odd, even pairs. So 1, 2, 3, 4, 5, 11, 12, 13, 14, 29, 30, 31. These are all sets of consecutive integers. If you're finding the consecutive integers, if you're trying to find the mean of the consecutive integers, rather than adding up all and dividing it by the total numbers, I'll just say simply find the median for those, because the median and mean is always same, or median or average is always same, and there happens to be a consecutive integers. So this is one of the property, like 1, 2, 3, 4, 5. It's a very basic common example which is taken always to explain this concept. 1, 2, 3, 4, 5, there are 5 terms, so the middle term is 3, my median happens to be 3. If I add all those numbers, 1, 2, 3, 4, 5, I can add those by 1 plus 2 plus 3 plus 4 plus 5, or I can add those by n and n plus 1 over 2. So that gives me a sum of 15, divided by total number of observations, which are 5. So 15 over 5 gets me 3. My median and arithmetic mean or average is same. So again, I repeat the concept. If you're dealing with the consecutive integers, then your median and average is same. If they say in the question that median and average is same for the same given data values, then definitely that data values are consecutive integers. So please be very focused about reading the question. This is something very interesting. Median always happens to be equals to average when there is a constant sum. So it's a bilateral symmetric term that we talk about. It's a very simple. If you have numbers like 1, 2, 3, 4, 5, 1 plus 5 would be equals to 2 plus 4, and 1 plus 5 would be equals to 2 plus 4. So like we have a bilateral symmetric terms. We have 6 terms here: 1, 2, 3, 4, 5, 6. 1 plus 6 would be equals to 2 plus 5. That would be equals to 3 plus 4. So in this particular scenario, your median and averages would be same. Now let's talk about one of the very you know easy but at times a tricky concept where GMAT often tries playing the game, because this is wherein they confuse the students, uh, putting the range, because the concept of range is very simple. It's a highest minus lowest, or the maximum value minus the minimum value. So the concept is very simple, but again, the type of question they trap or to form is a difficult one. So if you have a numbers minus 1, 3, 5, 9, of course, I've got three positives and one negative number. So negative happens to be the smallest. 9 becomes the positive. So that is the highest number here. 9 minus of minus 1 happens to be 10. So there's a difference of 10. Now let's talk about this question, which is based on the range. There are three numbers, A, B, and C, such that A is less than equals to B, and which is less than equals to C. If the range of A, B, and C is 10, which of the following cannot be the difference between A and B? So we'll try looking for the difference of A and B. What are the possible difference it could happen? We are already given the options 9, 10, and 11. So don't try putting your mindset for various other values. It's been pretty there that I have to mark my answers out of 9, 10, and 11, which are first, second, and third. So I'll consider that what all possible cases could be there where the differences of A and B could be 9, 10, and 11. And does it match to the given condition, which is A is less than equals to B, which is less than equals to C. And also the range happens to be 10. That is one of the major thing which I have to satisfy. So let's talk about this. The range concept is maximum minus minimum. Okay, we have been given three numbers. We are very good at it. We are checking the options for the difference between A and B. B being highest. I'll say I have to find the difference of B minus A. So option number one, if B minus A is 9, then I would say my numbers could be 1, 10, and 11. So that 10 minus 1 becomes 9, and the range is still 1 and 11, so that happens to be 10. So this is possible. Going with the second one, which is option number 2, which is 10. If my b minus a happens to be 10, I can take b and c both as 11. My number is 1. This happens to be 11, so difference is still the 10, and my range is still the 10. The range is between C and A because C is the highest and A is the lowest. But the third option, which says B minus A could be 11. If B minus A is 11, then C minus A would be greater than 11 because B is itself less than C or equals to C. So if B minus A is 11, then C minus A has to at least be 11 because range is already given as 10. So if range is 10, how can this B minus A be 11? So this is wherein we know that this is not possible. So this was a very basic concept of range, but again, this was most a logical concept or a question based on range, not too much of direct as we had seen for averages. Let's talk about the property of ranges. It's the same property that we have applied in the standard deviation, and I'll just repeat myself. For ranges, always make sure the scaling property always affects the range, which is multiplication or the division, but the addition and subtraction won't affect range, so it will always shift the same factor. So this was the same property that we applied for standard deviations also. Let's go ahead on range of one set. So if you are given range R maximum, so that could be capital M, greatest or the largest, minus minimum, which is M. Now, see, this is specifically for data sufficiency. For the range question, I'll go very slow on this. If there happens to be a range question in DS, so you have a maximum value M, you have a minimum value small m, so your range becomes R, which is a variable, equals to capital M minus M. We are already dealing with three variables now, the small r, capital M, small m. And we have got one more equation as well, which says R is equals to capital M minus M. So now I've got three variables and one equation. I need two more equations to solve this question to match it. And those two can easily be achieved by condition number 1 and 2 combined. So that gives me C as most likely answer. So this is for the range of one set when we deal with one set. Suppose we have been given two sets, then let's see how the number of variables and the equation changes. So suppose the set one is one, the set one gives me R1, M1 and small m1. So that happens to be three variables. For set R2, again, I'll have three variables. All in total, I've got six variables. I'll have two equations, R1 and R2. So I need four more equations. And now understand, if I need four more equations, I can maximum get only two equations, not four. So my possible and most likely answer would be E. We have questions coming on to it. Just hold on to it. That's not a big deal. We have questions coming on range, standard deviations in the DS specifically. Right now, our range, the PPTS or the slides as per the concept and questions. So right now we're dealing with the concept. And D, normal distribution. It's not that tricky, but again, again to be very much, you know, easy going with it. It deals with two factors, mean and standard deviation. It is a symmetrical across mean, and you would always have a bell-shaped frequency distribution graph. When you move towards right, you have one standard deviation, you have two standard deviation. When you move towards right, left, you have minus one standard deviation and minus two standard deviation. So suppose mean is 40 and your standard deviation is given as 5. When I move on to the right, I'll say 40 plus 5. Then I'll add up 40 plus 2 times 5. Going on the left, I'll go 40 minus 5 and 40 minus 2 times of 5. So this was the basic that we always talk about when it comes to normal distribution, but the major case that comes into normal distribution is this particular graph. The centermost part, which is visible as 0.34 on both the sides, that is the 34% of area that this particular curve covers. So 34 on the one side, it total gives me 68% of distribution is within the one standard deviation. When I say one standard deviation, that means from both left and right. Never get confused that your standard deviation is getting negative. It's symmetrical along the mean. So we have to take into left and right both. So 68% of area is covered from one standard deviation. That means from minus 1 SD to 1 SD, including M. And if you go ahead to it, more left and more right, you come across 13.5% of additional area. So 13.5 gives me total makes out to be 95% area covered in roughly this three standard deviations. And we have 0.025 also, which is 2.5, 2.5. So that again happens to be all in total. So this is how we get. So we have a 68% over 2, that happens to be 34. 95 over 2, that is within two standard deviations. So 95 over 2 gives me 47.5. 47.5 on the one hand side would distribute as 34 and 13.5. On the other side, it would also be 34 and 13.5. If we go on the 100% with the three standard deviation, it becomes 50% on both the sides, out of which 2.5, 13.5, and 34, that makes out to be distributed symmetrically. Now let's talk about this m minus 2d. This is again something which I've already told you. So m plus d, that is one standard deviation above the mean. M minus d is a standard deviation below the mean. So that's always rephrased as one standard deviation below the mean. M plus 2d would be two standard deviation above the mean. M minus 2d would be two standard deviation below the mean. Let's solve this question of a monkey tail, which is very pretty common question for GMAT quant. The length of a monkey's tail has a normal distribution. When it says a normal distribution, the graph should be very much there into my mind. If the average length of monkey's tail is 60 inches, the mean is given m as 60. Standard deviation is 10 inches. Very simple. 10 inches goes ahead on the right, 10 inches goes below from the left. What percent of the distribution of monkey's tail is between 70 and 80 inches? That's a pretty easy question, to be honest. How will you make out 70 inches? By adding up 10 to 60. So 60 plus 10, that is m plus d factor. How do you make it 80 inches? See, from 60, the both values are increasing. None of those values are less than 60. So you're already heading towards the right hand side of it. So that happens to be 60 plus 10, one time deviation. 60 plus 10 plus 10, that is two time deviation. So you're almost, indirectly or directly, you're covering the complete how much portion. Can you tell about this? So, 34 and 13.5. So almost covering would be 14%. The area lies between 1 and 2 would be 14% standard deviation. Let's talk about the modes. It's a pretty easy. Anything that repeats itself maximum number of times in the data set. So we deal with the term frequency. The number that has the highest frequency would be the mode, but it's not at all necessary that you would always have one mode. There are values and data set which is unimodal, which is bimodal. And when you talk about the normal distribution, the probability distribution, or Poisson distribution, so binomial distribution is bimodal. So again, always make sure that if there happens to be there could be two or three numbers which could be repetitive, they have the same kind of frequency. So in that particular factor, always remember that mode could be more than a number. And if that is possible, if that is possible, then we would always have the interpolation method. But have you ever thought about the fact that, if you're given a number like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, the first 10 consecutive integers maybe, what is the mode? 0. The mode has to be more than 1. So the repetition has to be always there, right? So, like in the first example, the mode of this particular data set is 2 because 2 is repeated thrice. The modes of this particular number is same 1, 2, and 3. So they're repeating same time. So this is how. Now, this is a question which is DS based with an unknown value or variable, which is X. Now, understand, I'll again solve the same question by the variable approach. For a list of 1, 1, 2, 2, 3, 3, 4, and X, what is the value of X? Now, understand, it's a mode based question. If you cannot relate whether it's a mode based question, you can see the numbers are repeating. Secondly, they have already given the word mode into the first condition. So we need to find the value of X. We are just dealing with one variable here, which is X. To solve the question for a one variable, I need one equation. Now I can get one equation from either of the condition, be it from condition 1 or condition 2. So in that particular case, I would say that my answer would be D, just because I'll need one equation and my conditions, both the conditions will give me each answers or each condition to equation to solve. So going ahead with this, I'll just consider the condition number 1 to solve the question. So just look at each condition. And these three principles which are there right now, recall three principles. These are the same. If you have a less amount of time, if you're running out of a time, you can probably mark your most likely answer once you master the variable approach. So let's go with the condition number 1. The mode of 1, 1, 2, 2, 3, 3, 4, and X is 2 only. It's not just 2, but it's 2 only. Now see, 1 is repeated twice, 2 is repeated twice, 3 is repeated twice right now. X is yet to be confirmed which one it should be, but let's say the data value should has more 2's than any other numbers. So that X should be 2 so that the mode becomes 2. So I get X equals to 2. That's a unique value. By unique value, if you get a unique value by common mistake type 2, this is something which I covered in my first webinar. Common mistake type 1, common mistake type 2. So I always talk about those. You can have those more into detail once you visit to our website. You can sign up and you can see the lessons. You would get hold of what is common mistake type 1, what is common mistake type 2, how why this person gets the answer without even solving. So this is all, you can get it through the website. Now coming back to the solution, X equals to 2, my answer, my this particular condition is sufficient. I have no issues solving it. Now let's go back to the second question. The average of 1, 1, 2, 2, 3, 3, 4, and X is 2.25. This is pretty easy. It's pretty easy. It has nothing to do with mode or anything in this world. I'll simply add up all the numbers, divide it by 8, and I'll put it equals to 2.25. That's a concept of average or arithmetic mean. After solving, I get X equals to 2. But now there is one information that is coming on the screen that you could see, and which is this, the tip 1. When your value of condition 1 and condition 2 happens to be same, likewise in our solution, X equals to 2, X equals to 2, in 95% your answer would be D. So if you can get hold of this thing before you want to solve, your solution is already ready. And this is wherein you save time. This is wherein we help a student to save time. This is where they are able to make 51. This is where we say that we have 90% of students, uh, or 90 plus percent of students getting Q49 or above, right? And this works, and that is more than sufficient to say. Okay, let's go ahead with this. Now we are just dealing with a DS question, guys. The concept is done. So let's put ourselves into variable approach. Now this question is median, standard deviation, and average. I told you every concept that I've covered will have a DS question at the end. So this is median, standard deviation, and average. Is the median of set A greater than the median of set B? So I have two sets. No, I have not been given the set. Understand, I've given no data values to it. I've just asked, is the median of set A greater than median of set B? If there was nothing given in this particular world, to me, I would have said the answer is E, because it could be less also, it could be equal also, it could be greater also. But this is a DS question for which I have relevant conditions to see through. So It's very simple. It's the relationship between median, standard deviation, and average. So understand, how many variables will I have? I'll have a lot of variables in this. I'll have a lot of variables into this. And then I'll require a lot of equations to solve this. So in that particular case, I would always say that the answer could be E. But let's go ahead and solve this particular question to make sure that our answer was E. And when I say answer is E, answer is E, it would be definitely, we'll be combining both the equations to solve this question. I'm not gonna, or we are not going to check every single condition. So don't check the conditions separately, just combine together. Condition number one says that the standard deviation of set A is greater than a standard deviation of set B. Now understand this, when they say greater, it's a standard deviation. That means the dispersion or the spread out of the data in the A set should be more than the B set. So what we could consider is, if set A is 1, 5, 6, 11, and 17, and the set B is 5, 5, 5, standard deviation of set B happens to be 0, because they are all same data or same numbers. So automatically standard deviation of set A is greater than set B. Now if I find the median of it, the median would be 6. If I find the average of it, because the condition 2 says the average of set A is greater than the average of set B, right? So we're dealing with that as well. The average of set A would be 8. And for 555, the average would be 5 and the median would be 5. So is the median of set A greater than the median of set B? Yes. But if I change the set B to 6, 7, 8 with a deviation of 1, so that's not a standard deviation. I'm not use the word standard deviation. With a deviation of 1, that means a difference of 1. Now, the standard deviation of set A is still greater than the standard deviation of set B, but my median is less. Oh, for first case, my median is 6, and for second case, my median is 7. But I'm not gonna take so much long solving this particular question, considering all those possible cases, and giving me a hard time. I know that there were a lot of variables involved in this question, and this question is all about, is median greater than on the basis of standard deviations and mean? My answer would be E. So I simply answer. So, this is wherein I work out. Relationship between medians of set A and set B is not sure. It could be, it cannot be. This is what I said earlier. My answer would be E. I gave you the answer before I clicked on the slides. And this is wherein variable approach lies. Let me tell you guys, even if the variable approach works for you in 15 questions, the rest of the question can easily be done within the time. And when you have a time, you have all possible things in this world to think about all the possible cases that is required to solve those DS questions. So make sure that you learn this. This is what I recommend and request to every one of you. Okay, let's go with this. 80 students, the data is 80, total number is 80. In a certain class K, that's a particular entity that is given, it's a class K, took a math test. What is the range of their test score? Now, do I have the numbers of this 80 students with me? I don't, right? But again, let's see what my condition says. The average score of 80 student is 80, okay? So let's say all the 80 student got 80. So my range becomes 0, but that is one of the possible cases. The median score of 80 student is 80. Now, this is a particular question on range, average, and median. Question before this was median, standard deviation, and mean. Now, this is a question that is relating median, average, which is mean, and the range. Now, again, I know that there would be a lot of variables and it would be answer E. I'll just take both the conditions combined together. Suppose my class K had all its students got 80. My median happens to be 80. My range happens to be 0. But if I just make a change to this, if I take some 70s, some 80s, two 80s, and then the 90s, then let me tell you, my range becomes 20 and my median still remains 80. So in this particular, average scores is 80. So in this, what happens is I'm not sure about the range, whether it's 0 or 20, and there could be any n number of possible combinations also. I don't say these are the only two possible combinations, but I mean to say these are the two combinations that are helping me to mark my answer as E. So, it's not sufficient, but I mark my answer just before solving the question. So, variable approach. Let's go ahead with this. The minor league players of professional baseball team X get paid substantially less than the major league players. Okay. If the number of players on the professional baseball team X in the minor league is 100, is the standard deviation of their salaries less than $100,000? Understand this. We have been given 100 as the number of players, and we are being asked, is this SD, the standard deviations of the salary, is less than $100,000? We have been given the average salary in the first condition for baseball team X. We have been given range. Question is a standard deviation, average, range. Question before the penultimate question was about the median, standard deviation, and mean. Answer was E. The second was median, range, and mean. Answer was E. Now, I don't say the answer would be E here. No, I'm just giving you the logic how we are, how GMAT forms the question. So over here, the relationship is between the range and the standard deviation. We do know that there is always a relation between mean, which is an average, and a standard deviation. But the relation between range and the standard deviation is being defined on the screen like this. If you could make a note of it, that would be good. The range is the difference between the maximum value and minimum value. That is, we know. So if a standard deviation is D, your range R, your D is less than equals to R over 2. This is one of the particular concept that would help you every time or most of the time in solving a question that is a standard deviation and range. Going ahead with this, see, we have a lot of variables. We need to deal with the relationships here. So if we talk about the relationship between standard deviation and range, that has to be strong. So now let's talk about the condition 2 first. It says the range of minor league salaries of professional baseball team X is $180,000. So I'll just put my D has to be less than equals to 180,000 divided by 2, which happens to be 90,000. So D is less than equals to $90,000. So now my standard deviation is 0, less than equals to D, less than equals to 90,000. My question was, is the standard deviation of their salary less than 100,000? Yes, it is. So my this particular condition 2 is sufficient. Now let's go on to condition number 1, which is actually a relationship between average and standard deviation. Average salary of the player is 220,000. Standard deviation cannot be found out right now because there is no relationship between the average salary. I've not got the data here. So we cannot determine here right now. I have a number of players, which is 100, but I don't have any particular data to be dispersed and spread the mean across. So my condition number 1 will not be a unique answer because it cannot be determined. So I still go with my answer as 2 alone is sufficient, and that is the answer B. So, this is a tricky question. This was definitely a tricky question, and you need to be very, very particular about when you solve the questions for range, standard deviation and mean together, median, mean, and standard deviation together, and all those. So this is what we have spoken about. Let's talk about the sets with the same elements. Range would be 0. So your maximum becomes the average or minimum becomes the average. This is one of the beautiful concepts. If your all terms in the sets are equal, your standard deviation is always 0 and your median equals to the average. So let's say John has been selling cars for 7 months and sold at most 7 cars each month. What was the standard deviation of the number of cars sold for 7 months? The question is on the standard deviation. The condition number 1 that I could see is on the range. Condition number 2 is on the average. Now see, the question is standard deviation, range, and mean. Again, they have been interrelating to this. Now, range is 0. Why? Because it's the condition say the range of the numbers of cars sold for 7 months is 0. So maximum equals to average or minimum equals to average. This is the first logic. Second, all terms in the set are equal. The standard deviation becomes zero, and median is equals to average. So these are the concept that will apply. Let's quickly modify and recheck the condition. John has sold at most 7 cars each month. At most seven. So that means the maximum is seven. So that means we have seven variables, and then we have one equation which says maximum equals to 7. So we need six more equations to solve. Uh, we cannot get the six more equations, so the answer would be E. Let's combine both conditions together. It says condition number one, the range is 0. So maximum minus minimum is 0. So all values are 7. So standard deviation becomes 0. So that happens to be unique answer. Condition 1 alone sufficient. That says, if we talk about condition number 2, that says the average number of cars sold per month for the 7 month is 7. Average will become the maximum value because range is 0. This is what we have learned, right? So all values are 7. Standard deviation is again 0. It's again a unique answer. Tip 1, it's the same. The value of condition 1 happens to be equal to value of condition 2. Your most likely answer would be D. I'm telling it to you, 95% plus times this tip is applied, and it's wonderfully working. So if you could get a hold of this, you can mark your answer as D. Now, you could write me on this. What do you think about the math revolution approach and versus the any sort of conventional approach which you have seen or which you may have following and have not worked for you? And for this, you can definitely go and check out the lessons. You can sign up. You can take in consideration all our courses. These are the solution courses which has variable approach, IV approach, and speed workout. You can often start with a trial pack, which you will definitely convert this into, you know, the long pack. So that's a 7 days trial that you could always have. It has 100 hours of video lessons, 27 topics, 1,500 practice question. Diagnostic test is one thing that you would always have. Uh, okay, when do we have no more than many modes? How to differentiate? So it all depends upon the data set, right? So if you have a data like 1, 2, 3, 4, 5, you have no modes because there are no numbers that are repeating. You need to see the frequency. The more any number which has a highest frequency will have the mode. So now suppose if I give you number set 1122, which one would be a mode? Your 1 and 2 both are the modes because both are repeating twice, right? But again, if I say 1 and 2, I'm giving you just two numbers, there's no mode. So that is how, we answer. Deepak also has the same question, and hope my answer is same for him also. Talking about the more one of the v- this is one package that is very close to my heart just because it's a shortcut to Q51. And again, the concern is like, there are a lot of students who take this package because they are already on the level of 45, 46. And how do we judge this? By just attempting a diagnostic test. It's a very different diagnostic test that gives you a clear understanding about your every area, your question types, where you require improvement. And this is wherein a lot of students have been discussing with me over the call also, which I've told you during my session today. You can always have a consultation call and we can talk about this. And all in one 3 months package, which is a GMAT beginners, anyone to so that is like a 3 months package. 2 months package is everyone who is starting with the math right now, being a math background, non-math background. And then we have a private tutoring, of course. And if you want it to be more organized, disciplined, then definitely it's you can avail the service of private tutoring. So you can definitely connect with me over the email, over the call. And if you wish to opt for either of the packages, be it a 3 months package or a 1 month or a trial pack, I could definitely think about giving you a wonderful discounts, maybe the coupons. So that is one thing you could write me back about it. But before that, I would love to listen about the webinars, the comments, the questions, and I would be more happy looking all you getting Q51 through variable and the IB approach. So please be always connected with us. Keep watching our lessons, keep watching our webinars, and this will always work for you. And this is just basic. I mean, like, you could get a free resources, definitely. Don't give up on math. I'm pretty sure you won't give up on math after today's webinar, and you can never ever be satisfied with the mid 40 and 30s, that is for sure. And you can write us an email at info@mathrevolution.com to understand the differentiation between various packages across. If you have a very particular question regarding verbal as well, or a quant, you can directly write me on my email, that's punit@mathrevolution.com. Right, so yeah, this is it. This is what we've done today, and thank you so much for your time, taking the time to connect with us, and we appreciate your interest. Keep connected with us. That is it. Thank you so much, and have a great time ahead. Goodbye. Bye bye.